Welcome to What That Means with Camille, where we take the confusion out of tech jargon and encourage more meaningful conversation about cybersecurity. Here is your host, Camille Morhart.
Hi, and welcome to this episode of Cybersecurity Inside. This is actually part 2, where we're specifically talking about intelligent systems research out of Intel Labs. We talked with Lama Nachman already, and she gave us an overview of some of the research that's happening within her lab. Now we're going to dive in with a subset of the lab and 3 PhD research scientists. We have an anthropologist, a computer scientist, and a user research scientist, all 3 with us, Dawn Nafus, Saurav Sahay, and Sinem Aslan. Welcome the 3 of you to this conversation. We're going to talk about emotion recognition today, and specifically how you get there with context-aware multimodal AI systems. And if that doesn't scare anybody who's listening, then you're probably not paying enough attention. We should be doing these things carefully and with a lot of insight, and ethicists and anthropologists, as well as computer scientists, all working together. So this is why we have a multidisciplinary crew on the call with us today. Let's start with Dawn, actually. Can you just tell us what is emotion recognition?
Essentially, it is the idea that we could build artificial intelligence systems to recognize different emotional states. And typically, there's a notion of input that's external. So most of the attempts tend to be around sort of facial expression, gaze. There's also some things that you can do linguistically to sort of see in text, people writing in a positive manner or a negative manner. Those are the kinds of typical scenarios I see, but I leave it to the real technical experts to refine that definition.
So then I'll ask Saurav actually to just take us one level down on the computer science side and just at a high level, and we'll work our way down to more depth here. But what are some of the different kinds of multimodal systems that we're using to recognize these things?
So emotion recognition technology is a technology where we're using things like, as Dawn mentioned, facial expressions and physiological sensing to audio sensing, using acoustic context, using for example, how you type on the keyboard, your typing speed and things like that, and takes into account all of these sensors to compute emotional states. And emotion is a topic of research that has several flavors and several theories. For example, there's a famous scientist, Ekman, who came up with these 5 basic emotions: happy, sad, neutral, and some of these states that typically many systems that we develop or model today try to have data for these emotion categories or the output classes, and then the models can emit out these states or detect these states. Now, going level deeper, emotion recognition is, as I said, a technology, but the actual use cases, for example, in the driving scenario, while you're driving, you have this attention. In my vehicle, I have this amazing attention assist feature that tells me when I'm drowsy. So this system is also using some flavor of sensing to detect whether am I alert or not. This could be one flavor of a use case of this technology that all tries to use similar features or do similar feature engineering to compute the output here.
Okay, and then Sinem, let's hear from you. Can you describe one of the projects that you're working on in the lab in the classroom?
One of the projects using context-aware multimodal AI technologies, we are trying to understand student engagement while they are engaged with digital content on their laptops. And here, like Saurav and Dawn mentioned, when you look at the state of art, majority of the researchers are looking at emotion understanding problem from the perspective of like facial emotions, the mimics that you are making, or your eyebrow movement, or all of those different things. But here at our lab, we are investigating this problem from more like multimodal kind of perspective, because we know that, right, we don't only show our emotions through our facial expressions. And especially when you think about a scenario where like a child is watching an instructional video on a laptop, probably most of the time his or her reactions in terms of the facial expressions might be subtle. So this is where we need really the complementary data sources, the interactions with the content platform, for instance. And at a high level, we try to understand engagement, but engagement is a multi-componential research construct for us because we know that learning is emotional as much as intellectual. So we are trying to understand whether a student is on task or off task during learning, but at the same time, the other level of engagement is on emotional engagement, where a student, whether they are confused, bored, or satisfied at any time of learning. So if we combine these two different pillars, we come up with this final engagement state. So if a student is on task and satisfied, then we map it as engaged. But if a student is on task but having some emotional problems, like maybe they are confused or bored, then we map it as maybe engaged. And if a student is off task, then we just map it as like not engaged at all. So these two dimensions gives us this broader perspective. And if you look at how we like evaluate emotional states, we look at like first of all, we use data from the laptop camera as vision modality. And we also use context and performance data from the content platform. And we extract features from these two modalities, which are then fused to provide us the final engagement state.
I've got to take a step back early in this conversation, and anybody feel free to answer. I'm kind of looking at Dawn maybe to kick us off on this one, but yikes. I mean, there's got to be a little bit of a yikes factor with that, because we're not even just, it's maybe even scary enough to be on camera or feel like, there's a camera that can monitor your facial expressions, which you may or may not be able to conceal. Now we're talking about all different kinds of sensors that, let's just assume ultimately you can't really face through all of them. So Dawn, help me understand what's kind of going to happen with this culturally. And
there's a yikes factor in a number of ways. I'll start personally. I work in this lab. I enjoy working with my colleagues. I respect what they do. And I believe Sinem when she says that we can support students in making sure that their emotional needs are met, which is, how I understand what Sinem's doing, or at least part of it. At the same time, I'll go off to anthropology conferences and I'll talk about emotion recognition. And the first thing people will say is, but you cannot fundamentally make a claim about somebody's emotional state for them. There's a kind of a power relationship here. They'll go on to sort of say that actually there's a lot more cultural variation than psychologists might. And sort of on and on it goes, right? So we have here like a scientific controversy, and I think it's a meaningful one, and actually working with people who sit on both sides of the controversy, it's like for me personally, it's whiplash, if I'm honest. When Sinem says, well, we use multimodality for a reason, and that reason in part is to get over that anthropologist sense of like, but you can't just read the faces. Mm-hmm. And I think part of what we're saying here in our lab is, no, you can't. We have to do something more to try to understand that context. But then the next layer, sort of where my work comes in, is to ask, okay, who's in control here? And who gets to make that claim about, is the student distressed? Is that student not distressed? To what end are we, saying, look, this student is on task or not? Who's going to win and who's going to lose in that scenario? And how are students going to grow up sort of feeling watched in that way? Now, that's not to say that there's not a history of schools and surveillance, and that experience of being in class and being watched is not an unfamiliar one. Despite computers, also a problem. But if we ask who's in charge, who benefits, and who gets to make these technologies at all, then we can start to unpick, okay, where's the benefits and where's the real risk?
So just to add to this kind of perspective, I think I totally understand the concerns around emotional understanding. And I think it's important to contextualize emotional understanding in the usage itself. So if you look at how teachers interact with children, they interact with them based on mostly their emotional state. If they see them confused, they need to take an action. and it's part of their day-to-day job. And when we give children with laptops, they lose like these all of the data that they have, which is the body language. Even if the classroom like is full of children and there is one teacher, it's really hard for them. This is what we identified from the ethnographic research that we have done. It's really hard for them to understand and monitor their engagement in real time. So in a way, we are making it more efficient. We are not creating some sort of a new data for them. This is the data that they already use on a day-to-day basis, but we are making it more effective and efficient for them. So I think it's kind of important to contextualize that. If you look at like work environment, even myself would not be okay with sharing my emotional states with my manager, right? Because that's not what she do on a daily basis. That's an extra information for her. But for a kind of a classroom scenario, it's already part of that context. And what we are doing is to really make it more efficient.
So maybe I will buy that on the small scale, and the individual, I guess, autonomy to say, whether a parent or a person, to say, okay, yes, I think this is going to help me learn better, I'm in, or no, thank you, right? But I guess now that we have people in distributed physical environments, which will, I assume, remain, henceforth to some degree, and we have AI kind of on the back end or in the cloud that can process this not on this one-on-one level, like you're saying, where it's the teacher getting a ping like, hey, the back row you've completely lost the back row. Now we're saying, well, AI could process people in their individual homes and provide information to some just broader platform or application, or being in control, I guess, whatever Dawn's kind of referencing. How do we deal with that kind of a scenario?
So in our case, we are not using it as a summative evaluation of like, okay, this student is 90% engaged, so she will get A from this class, right? That's not the usage that we are doing. What we are doing is we are sharing these learning analytics with the teacher so that the teacher use them as a baseline for starting the conversations with individual students. And from our own pilots, we have seen how kind of the teachers are utilizing these things. Like in one of the pilots, for instance, what we have seen was very interesting. So I would like to share it if that's okay. The teacher saw the child not so much engaged recently. And she went and approached the student and said, like, I see that you are not really engaged these last couple of days. And she realized that the student started to have a kind of an eye problem. And that was the reason he wasn't like watching the video, but he was still listening to it, because an instructional video, you can either watch or listen it. But the models say the student was not like engaged in this context. So if the teacher just relied on what the models say, then this student is really problematic, then it's a problem, right? But here in our usage, we are like asking the teacher to use that information as a starting point to create that conversation. The other way around, she doesn't know anything about the student. She doesn't know, are they struggling? Are they engaged? Are they following me? She doesn't have anything to act on. But now she has a baseline information. But of course, there is always a risk. Even for the most useful technologies we develop, people can use it for the negative purposes. But that's not our intent. This is like how we are envisioning in terms of how our teachers can use these technologies.
This field currently is evolving very fast, and people are aware that we don't want our AI to decide, to make decisions or create biases in the mind of, say, the decision makers for, say, children in the case when they're learning in a classroom. One of our collaborators, they're creating a digital platform where they're trying to use non-intrusive technology, not camera, but some other sensing modality to try to detect whether students are engaged or not. And based on that, they're not informing the teachers about what the students' issues, but how they can improve or how they can be better educators. Where are the idea of active listening? Where is it that kids are getting stuck? And if we can surface these issues also, that's actually very interesting. And there are other areas, for example, postpartum depression is an active research area where people have done a lot of research using sentiment analysis and emotion recognition to try to detect whether someone is depressed or going through postpartum depression or not. On people post a lot on Twitter and other social media platforms. It's all usage based, and there are definitely many good users of these technologies.
In a sense, what we're talking about is really kind of what makes responsible AI so hard. And it's really pushing, in a way, at the cutting edge of what responsible AI is. Because some of my colleagues right now are asking this question of when do things start to become unethical, and when is intent, in a sense, both the right place to start, but also not the whole story. There's a couple of things here. One is we always do need to ask that question. If we can satisfy ourselves that, in the example of the technology that Saurav and Sinem are talking about, if we can satisfy ourselves that the way we've got it designed is doing the right thing, we're going to be net positive here. Then, part of our job is also to then kind of do that kind of almost adversarial kind of scenario where we say, okay, let's put on the red hat in exactly the same way you would in security and say, okay, now what? Now it goes to the customer that whatever it is, and you can start to fill in the blanks, and you can start to see what starts like as a good idea. And then somebody might actually, for totally benign reasons, say, all right, well, let's just expand the scope a little bit. Let's just add one more feature. Or it doesn't even necessarily think about it. It's like, well, of course the school is going to want the data, right? That's transparency. And then all of a sudden, what started out pretty good and carefully done ends up being something that really is quite problematic. And so that's where I think the second thing comes in, which is a society, we need to be much tougher customers. In this example, when schools are starting to purchase this stuff, we need to be supporting them and asking the really hard questions about how does this work? How doesn't it work? What don't we want? What can we switch off? And with that kind of more skeptical customer base, then we can start to make sure that things, land where they want to land and don't end up having some mission creep into some territory that I don't think anybody wants.
Right, and it might be useful noting there is not a universal standard for privacy at this point, legally, or, literally from a standards perspective. There isn't one. We have various standards. Mm-hmm. But I did have a conversation with Claire Vishik, who's a fellow at Intel, specifically around privacy and its policy around the world. And it's not the same everywhere, and there's actually not a lot of common standards. There'd be very specific standards for specific things or regional standards, but you're kind of up against that as well.
As there should be. There's a lot of cultural variation in what we mean by privacy and when and where would you even want it? I have colleagues who do research in Papua New Guinea who literally cannot get away for like an hour because the villagers think he's lonely, and why would you ever do that, right?
Yeah, and I feel like it's important to give users option. If they believe that, for instance, this feature is useful for them, or maybe if they're parent, like in a way.
Right, opt-in versus universal, yeah.
So I think that giving that kind of agency to the users and individual users making those decisions, if I see a benefit, mm-hmm. right, then I would opt in. But if I don't, then I can opt out. Right.
So Saurav, can you ground us a little bit more? I know you work on some of the underlying algorithms, being a computer scientist. What actually are some of these systems? When I talked with Lemma, she did talk about looking at how human bodies interfere with Wi-Fi signals and that we can actually detect movement and presence through Wi-Fi signals. I'm wondering if you can tell us what some of these other, I think everybody's heard of, cameras. There's gesture recognition. There's this new kind of natural language processing, though it's been around for a while, seems to be getting a lot of traction now. So can you tell us what the different kinds of sensors are that are getting at emotion recognition?
I work in the area of multimodal dialogue and interaction. In this world, we work on conversational AI technologies. So we work on things like multimodal language understanding and generation, dialogue management, and then creating solutions that can make these interactions, either human AI interaction or AI interaction, very efficient. For emotion recognition, we are looking at, say, audio, vision, and text modality primarily, and also heart rate. There are other researchers in the team who try to bring in heart rate and other physiological sensing. We have BCI, brain computer interface, and we have typing speed. I mentioned, like context awareness. How do you interact with your machine, and how can you capture various what application you're using, what's your say speaking rate, what's your typing speed. All of these are relevant to detecting signal like emotion, or emotion in the use case could become, say, your frustration or your confusion or some other signal that is fine tuned for the actual use case that you're trying to develop.
So you're talking about something like when I type, which I guess typing's probably going to be out the door at some point here. But, if I start hitting the keys really hard and typing really fast, then you can assume I feel really compelled or maybe angry, or you might have some kind of a subset of emotions. You're narrowing it down. This is not a calm, happy space based on how you're typing.
You could or you could not, but depending on your baseline. So now, if you have been typing calmly most of the time, but then suddenly your typing speed goes up quite a lot, or you're punching on keys hard. So it's a signal that then, with the other context together, you can come up with some inferences. And more often than not, we still use supervised learning methods. So you have the signal, you have the training data to create the actual systems today. So then, yeah, you can make fairly good conclusions about how your typing speed is influencing your affective state in a way.
Okay, one more question on this front. You said human brain interface, which I do think is one of those buzzwords also. I know these aren't buzzwords for any of you guys. They're like just actually what you're studying every day. But for the rest of us, when you talk about human brain interface, you're going to have to help me out. I understand like eye movement and gestures of my hands, but now you're connecting sort of directly or indirectly through the brain. Tell us what that is exactly.
So these are like EEG sensors, for example. You can plug in these diodes on your head and try to capture or try to sense the signal. Similarly, Wi-Fi, for example, there's a lot of work in our lab where people are using this Wi-Fi sensing to even detect whether you are near the machine or away from the machine, which room are you in, or what kind of action you're doing. So BCI is very strong. So, for example, what some researchers are trying to do is to try to link the BCI signal with language, and that together can help, say, patients like people suffering with ALS, to help them with predictive text, or help them communicate, help them type. So currently we use other ways to do predictive tests, but there's a researcher in our team who's trying to link the neural as computation of thinking with typing, with language model technology, to make it even faster, to be able to predict what the person might say next and help them communicate better.
I get like autofill because I've typed the first part of a word, but how are you going to predict what somebody's going to say next? What's it basing itself on? The first part of the sentence that they've said out loud, or what they're thinking, and how do you tell what they're thinking?
That can be done quite in a very sophisticated manner today because of all the advances that we have seen in language model technology. Probably you've heard GPT-2 BERT style language models today that are very large language models trained on gigabytes of data that have learned how sentences are written. And as you start typing, there's a lot of personalization technology also that can then cue in on your previous word, your, say, past spoken utterances or your written text, and help to predict. And that's what we're using.
Now you're not talking about I've given you the first part of a sentence. I haven't yet. It's still inside my brain. So now how are you figuring that out?
So you're talking about exactly the signal that we capture from EEG, for example. You can think of it as some sort of a cold start versus priming the system to predict the next entry. And as I again said, these are supervised models. So you take in a lot of the signal and you capture data about how people are typing, and then combine the two different modalities to improve, say, the language model technology with the neural signals that you can capture to do predictive text.
one of the things that anthropology really does is it tries to understand what metaphors are people using to understand what it is they're doing. And I do think it's notable that we're in a time where sort of notions of the brain, right, both in sort of human brain interface or computer brain interfaces, neuromorphic computing, which is a way of taking inspiration from one understanding of what a brain is, right, to sort of do the hardware, right, to sort of labeling everything smart, right. It's sort of interesting that we're kind of in this moment where there's this sort of preoccupation with the human brain. It's never anybody else's brain, it's always the human, right, which is sort of an evolution from sort of earlier kind of more machinic notions, right, that like, but the economy is the machine, right, everything is kind of quite mechanical. So we can sort of see this as a kind of a cultural moment. But it's also a bias in a way, because if you think about other values outside of Silicon Valley, right, you might arrive actually at different metaphors that might be more inspirational, right? Ecological metaphors, metaphors to do with kinship or family, or, we can have a nice big laundry list. But it's just notable that there's this cultural preoccupation that is driving computing in some directions and not necessarily others.
You mean driving computing toward like the human brain and how we're processing and our emotional recognition versus some other value that might be out there?
Exactly. Yep.
Dawn, one other question for you is, you did mention the word bias, and I would like to try to have some kind of a brief conversation. Maybe I'll have to talk with each one of you separately at another time, but I think everybody's heard, everybody has to be aware at this point that there can be biases in AI models. And a lot of times those biases reflect prior structural inequities, et cetera, in societal systems. Help us understand, like, what have we not thought of yet? What are biases that we're either, inadvertently introducing by correcting the ones we're aware of, or, what's kind of the latest thinking on this topic?
So you're right, especially the sort of the big, broad, US-centric, demographic categories, right? Race and gender. There's a ton of work that's gone into that, and most people are aware of what's going on with that. And where that's changed now is to really doing and emphasizing more research in terms of both the technology and the use of technology that's really led by and for people who are typically adversely affected by those biases. So a shift, I think, that's happened probably in the last 2 years. There's been more and more calls for that kind of thing, and we're starting to see some real resources go in that direction. For folks, who are more like us here at Intel and these big, large companies, even just types of underappreciated biases, like, for example, disabilities, like the one that Sinem mentioned. There's an eye issue, well, that's going to affect a whole lot of other technologies. These very context specific, right? What's going to affect my actual technology? Well, there's going to be a lot of variation in that, but it's really easy to say race and gender in a big, broad way. And then I'd say finally, and again, this comes from my discipline, is there's a lot of work that's been going on to really articulate what indigenous data sovereignty is and looks like, right? So that's that sort of taking seriously this idea that indigenous people have control over their land and cultural rights and social rights and all the rest of it. And if we acknowledge that, then we also have to acknowledge sovereignty over data. And so there's really great work coming out of New Zealand, Canada, to really sort of flesh out what this looked like. And so if I had a little crystal ball, I would say for that stuff to sort of come into these technology development conversations, I think it's just going to unpack a whole lot of stuff that we have yet to even touch, and it's going to be super hard, but I think good in the end.
Sinem, what would you like to add as kind of a final thought here? Unfortunately, I think we have to wrap up soon. So give us something that you think is sort of a hot topic maybe we haven't touched on enough in this conversation.
Of course, talking about the bias that these machine learning models can produce, but there is also the human bias. For my own research, I know that from literature, teachers are, for instance, biased towards some kids. They always give verbal interventions to those kids, or they always praise certain kids, I mean, some of them at least. So there is also human bias involved in these things. To me, it might be more dangerous. we can potentially control the bias in machine learning models by controlling the data set that we are kind of training them. But on the other hand, there is also the bias that humans do on a day-to-day basis. So how do we balance these two? Are we giving maybe more data to get rid of some of the human bias? That's another thing that I think we should think about.
You guys, oh my God, such a fascinating conversation. And I can't believe each one of you should talk to for probably 2 or 3 hours. I might need to get into some longer conversations like that because it's so interesting. I think really psychology, anthropology, computer science, all sitting down together in the same lab, but also, like you're saying, Dawn, you're attending anthropology conferences where other whole conversations are happening and bringing that back into the lab. And of course, you three are a subset of this lab too. I just want to mention this is Intelligent Systems Research Lab, which has many other disciplines as well. And so just really wanted to give a little bit more insight into some of the people on the team and what they're thinking and studying. So Sinem, Saurav, and Dawn, thank you so much for joining today.
Thank you.
Thank you. Yeah, thank you for having us.
Never miss an episode of What That Means with Camille by following us here on YouTube. You can also find episodes wherever you get your podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.